everyone. Thank you very much for watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie for class? Okay, very good. And welcome to Algebra 2. We're going to continue our review for Semester A's exam coming up. This is part 3 of that program. And remember that these live streams, in addition to Practice Exam 1, that will be available in the description, or a link to it in the description of this video, should be used as diagnostic tools for you to identify subtopics that you need to most improve upon. If you find anything in this video that is a little bit troublesome or confusing to you, even after we finish, I'm going to be releasing independent practice sets and quick drill sets A and B that will supplement this material. After going through those exercises, which the independent practice set is going to be a large assignment with many problems throughout many varying levels of difficulty, and quick drill sets A and B are going to be more difficult problems, shorter assignments, but more difficult problems, and focusing in on word problems and real-life scenarios. After using those resources, there'll then be Practice Exam 2 and Practice Exam 3 that there'll be solution videos for you to fine-tune your skills in preparation for your midterm. If you have any questions, then please let me know. You can use the comment section of this video, or you can contact me on my social media accounts. As always, this is a live stream, so let me share my screen with you, and just know that there is a little bit of a delay, but I'll mitigate that as much as possible. The hard copy to this assignment will be available on Certified Learning Center's website. There'll be a link in the description to it. Just make sure that you're looking at the correct document, and you know that you are if you see in the upper right-hand corner a reference number that is 2149-12. I know that's a kind of odd number, but there's a lot of documents on from my YouTube channel. So I'll circle it right here. It's 2149-12. That way you know that you're looking at the right document and you're all set. But otherwise, let's just jump right into it. So let's look at the first question. And that is, we're going to look at writing an equation for slope-intercept form, point-slope form, and standard form that go through particular points. So here we're looking for slope-intercept form, point-slope form, and standard form of a line that goes through the points 2, 4 and 10, 12. I'm going to give you 4 minutes. After 1 minute, I'll start to solve to give you some hints. I'll keep track of the time in the upper left-hand corner, and I'll update it as best as I can per minute. Okay, so for number one, starting with slope-intercept form, which is really the preferred form, that's the one that's easiest to use. I mean, some people can use point-slope form, but slope-intercept form is kind of the gold standard in linear algebra. That way it's really easy to visualize once you get used to it, what the line looks like. Because you have a starting point, which is your b value, your y-intercept. You can immediately locate the point in which it crosses the y-axis. And then from that point, you know what direction and what magnitude it's traveling from the slope. The slope tells you how steep or what type of increase from that initial point the graph obtains or the function has. So slope-intercept form is y equals mx plus b. Y is your y-coordinate at any output. M is your slope. X is your x-coordinate at any input. And B is your y-intercept. So in the equation, you're always going to have an x and a y. So really what you're trying to figure out here in order to write the equation is to calculate the value of M and B. So we can calculate the slope using the equation y2 minus y1 divided by x2 minus x1. So we have 12 minus 4 over 10 minus 2. That's going to give us 8 over 8, which gives us a slope of 1. So if our slope is 1, we can start with the general form y is equal to mx plus b. And what I'm going to do is I'm going to substitute in the coordinates of one of the points that they give me and the calculated value for slope. So I'm going to say that 4 is equal to the slope 1 times x, which is 2 at that point. The output is 4 when the input is 2. And then plus b. So this allows me to solve for the b value. 2 times 1 is 2. Subtracting 2 on both sides, I'm going to find that b is equal to 2. So I know that m is equal to 1 and b is equal to 2. That's all the information I need to write the slope-intercept form. So I'm going to have y is equal to 1x plus 2, which is the same exact thing as y is equal to x plus 2. For point-slope form, we already have the slope is 1, and we know one of the points. You can use either 2 comma 4, or you could use 10 comma 12. It doesn't matter which you use. So here I just use 2 comma 4. So we'd have the quantity y minus 4 is equal to 1 times x minus 2. So that's point-slope form in purple. And then we have standard form in blue. Now, the name is kind of misleading. It's kind of a misnomer because standard form is not really that standard. We don't really use it that often because it doesn't tell us very much just by looking at it. You have to rearrange for y in order to get at the actual information. But if they ask us to put this in standard form is in the is the form ax plus by is equal to c, some constant number. So if we take the slope-intercept form of y is equal to x plus 2, basically you're just moving all of the x's and all of the y's to one side, and you're moving the constants to the other side. So subtracting that x over, we're going to get negative x plus y is equal to 2. And if I wanted to put in coefficients to make it very clear, then that would be negative 1x plus 1y is equal to 2. But the 1's as coefficients are unnecessary. If you have any questions, then please let me know. Otherwise, let's look at question number 2. So I'd like you to write an equation in slope-intercept form, point-slope form, and standard form that goes through the points 3 comma 1 and 5 comma 9. So I'll give you 4 minutes. After 1 minute, I'll start to solve. Okay, so for this guy, remember slope-intercept form, y is equal to mx plus b. So first, if we have two coordinate points, we can solve for the slope using y2 minus y1 over x2 minus x1. So we're going to get 9 minus 1 over 5 minus 3. That's going to give us 8 over 2, which is going to give us a slope of 4. So if m is equal to 4, now I can substitute the coordinates of one of the points, and there's no reason to make life hard for yourself. So pick the easier to work with numbers. So I picked 3 and 1 rather than 5 and 9. So 1, we can set 1 equal to 4 times 3 because the y coordinate of 1 has to be equal to the slope of m times x, which is 3. So 1 is equal to 4 times 3 plus b. 4 times 3 is 12. And then subtracting 12 on both sides to solve for b, we're going to get b is equal to negative 11. Now that we know b and we know m, we can write the slope-intercept form as y is equal to 4x minus 11. Once we know the slope and we have at least one point, we can immediately write the point-slope form. So we have y minus y1 is equal to m times x minus x1. So substituting 3 and 1 in for the x and y coordinates respectively, we get y minus 1 is equal to 4 times the quantity x minus 3. And lastly, to write the equation in standard form, you kind of have to take either of the others and simplify it and rearrange it. So we're just trying to push all of the x's and all of the y's to one side and all of the non-variable numbers, all of the constants, to the other. So I just took the slope-intercept form of y is equal to 4x minus 11, and I subtracted away the 4x on both sides, leaving me with negative 4x plus y is equal to negative 11. If you have any questions, then please let me know. Otherwise, let's look at question 3. Sorry, a little bit of a delay. So let's write an equation in slope-intercept form, point-slope form, and standard form that goes through the points of 5, 8 and 10, 18. So I'll give you 4 minutes. After 1 minute, I'll start to solve. Okay, so for number 3, starting with the points 5, 8 and 10, 18, we can calculate the slope using the expression y2 minus y1 over x2 minus x1. So we're going to get 18 minus 8 divided by 10 minus 5. 18 minus 8 is 10, 10 minus 5 is 5, 10 divided by 5 is 2. So we're going to have a slope here of positive 2. Now we have a point and the slope, so now we can calculate the y-intercept of the slope-intercept form, y is equal to mx plus b, by substituting in the coordinates of 5, x and the slope of 2. So we're going to get 8 is equal to 2 times 5 plus b. 8 is the y-coordinate, 2 is the slope, 5 is the x-coordinate, and b is the unknown y-intercept that we're solving for. 2 times 5 is 10. So subtracting 10 on both sides, we're going to get b is equal to negative 2. So substituting that value for negative 2, now that we know that b is equal to negative 2 and m is equal to positive 2, that's all the information we need to write the actual equation in slope-intercept form. So now we know that y is equal to 2x minus 2. For point-slope form, all we need is one point and the slope, both of which we have. So we know that the point 5, 8 is on this line, and the line has a slope of 2. So we're going to have y minus 8 is equal to 2 times the quantity x minus 5. And lastly, to convert this into standard form, if we take the slope-intercept form and just move all of the variables to the left and make sure all of the constants are to the right, we're going to have, subtracting 2x on both sides, we'll have negative 2x plus y is equal to 2. Equal to negative 2. If you have any questions, then please let me know. Otherwise, let's look at question number 4. Question number 4 is going to be a little bit different because now instead of giving you 2 points, I'm giving you a point and the actual slope. So question 4 asks, write an equation in slope-intercept form, point-slope form, and standard form that goes through the point 1, 2 and has a slope of 1. I'm going to give you 4 minutes. After 1 minute, I'll start to solve. Okay, so now that we have the slope and 1 point, we can immediately, we don't need to calculate slope because I gave it to us. So if the slope is equal to 1, if we substitute that into the slope-intercept form of y is equal to mx plus b, and then substitute substitute the coordinates of the point that they give us, 1, 2, we can solve for the y-intercept value of b. So when we substitute in, ultimately we're going to get 2 is equal to 1 times 1 plus b. That's because 2 is the y-coordinate of the point, 1 is the slope, 1 is also the x-coordinate of the point, and b is the unknown value we're solving for. 1 times 1 is 1, so 2 is equal to 1 plus b. And subtracting 1 on both sides, we're going to find that b is equal to 1. So if b is equal to positive 1, then y is going to be equal to a slope of positive 1 times x plus positive 1, or in other words, y is equal to x plus 1. For point slope form, they gave us everything that we need. We literally did not need to calculate anything. We just need to put it in the correct format. So we're going to have y minus 2 is equal to 1 times x minus 1. And finally, for standard form, we're going to take the slope-intercept form, y is equal to x plus 1, and we're going to isolate it for the variables on the left, pushing the constants to the right. So when I subtract away x, I'm going to get negative x plus y is equal to 1. If you have any questions, then please let me know. Otherwise, let's look at question number 5. It's going to be similar to question 4. So I'd like you to please write an equation in slope-intercept form, point-slope form, and standard form that goes through the point 6, 4 and has a slope of 2. So I'll give you 4 minutes. After 1 minute, I'll start to solve. Okay, so if we're going through the point 6 comma 4 and we have a slope of 2, then we can substitute in 2 for m in the slope-intercept form of y is equal to mx plus b. And we can also substitute in 4 for y and 6 for x because those are the coordinates of the given point. That gives us 4 is equal to 2 times 6 plus b. 2 times 6 is 12. Subtracting 12 on both sides is going to give us b is equal to negative 8. So if b is equal to negative 8 and m is equal to 2, then we have all the information we need to write the slope-intercept form of this line. So y is going to be equal to 2x minus 8. For point slope form, all we need, we have everything that we need. We don't have to calculate anything. So y minus 4 is going to be equal to 2 times x minus 6, just substituting in the slope and the coordinates of the given point. To write the standard form, we're going to take the slope-intercept form and just isolate all the variables on the left side and then push and make sure all of the constants are on the right side. So subtracting 2x on both sides, we're going to get negative 2x plus y is equal to negative 8. If you have any questions, then please let me know. Otherwise, let's look at the last problem for today. This will take us up to the end of class. So number 6, please write an equation in slope-intercept form, point slope form, and standard form that goes through the point 3 comma 5 and has a slope of negative 5. So I'll give you 4 minutes, and after 1 minute I'll start to solve. Okay, so for number 6, we're given the point 3 comma 5, and we're given a slope of -5. So if we input the coordinates 5 for y, 3 for x, and -5 for m into the equation y is equal to mx plus b, we can solve for the b value, the y-intercept value. So that gives us 5 is equal to -5 times 3 plus b. -5 times 3 is -15, so we're going to have 5 is equal to -15 plus b. Adding 15 to both sides, that's going to give us 20 is equal to b. So this function, this line, crosses the y-intercept at positive 20, allowing us to write the overall slope-intercept form of y is equal to -5x plus 20. For point slope form, we're just going to insert the coordinates of the given point and the value of the slope that's given. So we're going to have y minus 5 is equal to -5 times x minus 3. And for the standard form, if we just take the slope-intercept form and isolate the variables on one side, the x's and the y's on the left, and keep the constants on the right, we would add 5x to both sides, and so that's going to give us 5x plus y is equal to 20. If you have any questions on anything that we've done today, then please let me know either in the comments or on my social media accounts. Remember that if anything troubled you also, there's going to be additional uploads, uploaded videos for the independent practice set and quick drill sets A and B. So watch out for those, as well as the practice exams 1 through 3 to help you out before your exam. Thank you guys very much for watching, and if you find these videos helpful, please like, subscribe, and share with your friends. Otherwise, Dr. Todd, you want to say goodbye to everybody? Been sleeping very quietly. I think that deserves a cookie. You want to say bye? Can you sit? Can you sit? Can you say bye? Can you say bye? Good boy. Good, good. Very good. That was a good bye. Thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all tomorrow.